Welcome to EPG Pathsala Architecture lecture series for MArch students. In this lecture, we are going to see about wind energy and small hydro as part 1 of this lecture. And these are the learning objectives: wind power, current scenario, the wind turbine aspects, wind power, wind energy equations, case studies, small hydro power, current scenario, scale and schematic of small hydro power components and working principle. This is about the wind energy. So, when we think about wind energy, and people think it occupies large area and it needs a lot of land and the cultivation may be affected. It is not at all. So, underneath the wind turbines we can have the form like this. So, the cultivation may not be affected and the irrigation cannot be affected. So, underneath the wind farm we can have usual cultivation without affecting it. And this is about the current scenario with respect to wind energy. Wind energy installed capacities about 28,082.95 megawatt till September 2016, which is remarkable, and we keep a 4th position in the world in terms of wind energy installed capacity. And the number 1 is China, and followed by US and Germany and India. So, India has installed and 28,000 plus megawatt capacity, and among renewables it plays a vital role, and entire renewables through which we could generate say 45,916.94 megawatt of electricity, and out of which and 60% is from wind energy in the Indian energy scenario. And among all renewable energy sources, wind is playing a vital role. It is quite mature technology all over the world, and in Northern America and European countries and Asia and almost all the countries, they are showing interest towards wind energy, and they have installed enormous amount of wind turbines to generate electricity. This is about the potential of wind energy, and when we look at the wind energy, so 100,000 megawatt, 1,04,000 megawatt, which is very high potential we have in the country. And out of this we have around say 30% already we have installed, rest in few years, and we can complete an entire potential for the wind energy. And this is about the power generation split up, and from wind energy, and we are generating about 33.03 billion units of electricity, which is really high when compared with other renewable energy sources. And this is about the country map, and here the Tamil Nadu has installed maximum wind energy generators. 7,000 plus megawatt is from Tamil Nadu, and it is pioneering state in the country, and followed by Rajasthan and Gujarat, and they have installed reasonably good amount of wind turbine generators, of course, and Maharashtra is also picking up, and again Karnataka and Madhya Pradesh, and they are all picking up in terms of installation of wind energy systems. And this is about the growth path. According to 2011 and 12, we had only 17,000 plus megawatt of electricity capacity, and then it increases over the years, and by the year 2021 and 22 it is expected about 60,000 megawatt, and that is when we look at the potentials, and we have good amount of potential, and it was estimated at 80 meters hub height. And about 20 years back, there was estimation at 50 meters hub height, which was about 50,000 megawatt. Now, and with 80 meters hub height, we could have about 100,000 megawatt of capacity. And this is about brief introduction about the wind power. The conversion of wind energy to electrical energy is one of the most successful renewable energy technologies. The kinetic energy of a moving body is proportional to its mass or weight. The kinetic energy in the wind thus depends on the density of the air, that is its mass per unit volume. So, and the kinetic energy of the wind is converted into mechanical energy and then electrical energy, and the density of air is also playing a good role, as well as the velocity of the wind. In other words, the heavier the air, the more energy is received by the turbine. All over the world, the annual wind energy market is growing with over 30% rate, which is phenomenal. And these are the causes of wind, how we get the wind flow, wind velocity, and then the reasons are rotation of the earth. The earth is revolving, and because of the rotation of the earth, we have the wind velocity, wind flow around the earth. And apart from it, uneven heating of the atmosphere by the sun. The one side it is quite warm, another side may be cold. For example, in Asia, in India, now we have the cold climate, whereas in Australia they have some warm climate, and from the cold we have high density of the air. At the warm side we have less density of the air, and because of the density difference, the wind is flowing from hot side to the from cold side to the hot side. And apart from it, the irregularities of the earth surface, and the earth surface is not even and it is irregular. It is advantage. Because of that, we get wind flow pattern, and because of the mountains and valleys, and we get the wind flow across it. And here you see some cold air upon the sea side and warm air on the land. So, from sea side to the land side, the wind is flowing, because of the cold, the density of the air is high, and because of the warm condition, the density of the air is low, and from higher density to the lower density, the wind is flowing. And this is about the distribution of wind speeds. At a given location, the wind speed varies over a day and over different seasons. The wind velocity, the wind speed may not be uniform throughout the day, and morning we have one speed, and afternoon maybe another speed, and evening maybe other speed. Like the speed will be varying throughout the day, and same way different seasons. For example, in India, particularly the southern part of Tamil Nadu, in the month of May, June, July till August, we have very good wind velocity. At the same time, the month of December and January up to February, we have very poor wind velocity. So, because in the seasonal, it is also seasonal, and not only that, and even in one day, in 124 hours, we have different wind speed. The power extracted from wind turbine depends on the cube of the wind speed, and the histogram presents the probability of wind speed to be in certain limits. It can also be presented in the form of number of hours. The total hours in 1 year, that is 365 into 24, it is about 8,760 hours. And this is about the wind speed histogram, and here you see the hours in year, and here the wind speed, that is meter per second, and from 4 meter till say 19, and this is very good wind speed. And if it is less than 4 meter per second, and with that wind velocity, the turbine cannot be operated, that is minimum cut-in speed, it is about 4 meter per second. Same way above 17 meter per second, and that is about cut off. So, after that, so it may not be useful, and only from 4 to 17, and this is very good region, and before we install the wind turbine generator, and we have to get the meteorological data and annual wind speed we have to assess, and how many hours of 4 meter per second wind speed or 7 meter per second wind speed or 10 meter per second wind speed, and so how many hours we have for different wind speed pattern. So, these kind of meteorological data is necessary before we install the wind turbine generators. And this is about Beaufort scale, and the force is given from 0 to 12, and this is about the strength. When the number increases, the intensity is also increasing and the speed is increasing kilometer per hour, and these are the various effects is given. For example, 0 force means it is very calm, and 0 to 1 kilometer per hour, and smoke rises vertically, the effect is not that much. Light air, and the force number is 1, and speed is about 1 to 5 kilometer per hour, and smoke drifts slowly, and it goes on like that, and we have various forces and strength and the speed limit, and then various effects of it. This is about height above the surface, and this is about the wind speed increasing factor, and when the height increases and the wind speed is also increasing. So, when we go up and up, we get very good wind velocity. So, that is why the hub height should be maximum. So, when we increase the height, we get more wind speed, and when there is more wind speed, we get more output. And some environmental issues, and it creates noise pollution because of mechanical components, particularly the gearbox, and it gives aerodynamic noise. And the wind turbine produces electromagnetic interference when placed between radio, television stations, etc. It reflects some electromagnetic radiation, and these are all some environmental issues, and it creates noise pollution, of course, because of the gearbox, and sometimes it will affect the electromagnetic radiation, and it may affect the telecast of radio and TV. And it also produces visual signing because of reflection and refraction, which depends upon the turbine size and number of turbines in wind farm design, etc. And yes, and when you look at the big wind farm, and it creates some visual shining effect because of the reflection and refraction. And safety consideration for, like, because of accidental breaking of a blade. If the blade falls down, it creates huge accident, because it's such a long blade, about over 80 meters long, and if it falls down, it creates accident, and fatal collisions of birds caused by rotation of turbine blades. When the turbine blades are rotating, it may kill the birds, and these are all some environmental issues. And the selection of site for wind energy conversion system. And before we select the system, we have to see the availability of anemometry data. So, throughout the year, what kind of wind speed it is prevailing, and we have to have the anemometry data. Anemometer is used to measure the wind velocity and high annual average wind speed, and in that particular location, throughout the year we have to have the data, and you should have high annual average wind speed, and wind structure at the proposed site, and altitude of the proposed site, what is the height of the proposed site, terrain and its aerodynamic in nature, and local ecology, and all these parameters have to be considered when we select the suitable site for the installation of wind turbine generator. And these are the characteristics of a good wind power site, and high annual wind speed, it is one of the best character the wind farm should have. And then apart from it, an open plain or an open shoreline, and if there is plain area, wind velocity will be very good, and the open shoreline on the shore, and definitely the wind velocity will be very good. And the mountain gap, the valleys, and the top of a smooth, a well rounded hill with slopes lying on a flat plain or located on an island in a lake or sea. On the lake side and the sea side and island side or mountain gap, plain area or shoreline, these are all wonderful characteristics of a good wind power site, and should be no full obstructions within a radius of 3 km, and around the wind farm there should not be any obstructions. And these are the methods of wind recording, and we are supposed to record the wind velocity every minute, and the human observation and logbook. So, I mean before 20-30 years ago, people used to note down in the logbook, but the mechanical counter anemometers will be there, and it will measure the wind speed, and it will be noted down in the logbook. But nowadays data loggers are there, and each and every second and data could be stored in the data logger, and the continuous record of velocity and directions also could be measured. The wind direction and the wind velocity, everything can be recorded continually, and these are the wind monitoring stations in India. Here we could see hundreds and hundreds of stations from Kashmir to Tamil Nadu, and all over the country we have wind monitoring stations. And through the monitoring stations we could measure the wind velocity, and we could measure the humidity, the temperature, everything, all meteorological data could be measured through the wind monitoring stations, and it will be stored in the center office, that is National Institute of Wind Energy in Chennai, and all the data will come and get it stored at the center point, and whoever wants to install the wind farms, and they can get the data from National Institute of Wind Energy, that is NIWE, and the data for the over the years could be obtained, and so that we can calculate what is the annual mean speed of that particular location, and if it is favorable, and then we can go for the installation. And this is about the wind resource assessment, and the wind power classes are mentioned here 1 to 7, and the wind speed, the number 1 class, that is 0 to 5.6, and for the class number 2 it is 5.6 to 6.4, and it goes on till 7, and 7 8.8 to 11.9, and for the various classes and the various wind speeds are given, and the wind power density at 50 meters height, that is watt per meter square, and 0 to 100 when the class is 1, and the class is 2, it is about 200 to 300 watt per meter square, that is the wind power density. When the speed is 5.6 to 6.4, it is marginal. So, the poor, this is poor site, we cannot take this site, and this is marginal, okay, above cut in speed, and the wind power density is also reasonable. So, marginally the site is good. The third class, it is fair, and fourth class, it is good site, and the wind speed is always 7.0 to 7.5, that is wonderful. An excellent site number class 5, and wind power density is about 500 to 600 watt per meter square. Outstanding when the wind speed exceeds 8 meter per second, and when the wind power is density is about 600 to 800, very outstanding site. If the wind speed crosses 8.8 and up to 11.9, when the wind power density is 800 to 2000, it is superb site. And according to the wind speed and wind power density, and so we have to choose the right location, and from 2 onwards it is the right location, but then the last 3 or 4 it is really wonderful sites. And this is about the wind power. Wind power is directly proportional to wind velocity, V cube. Theoretical available power, that is the power that is equal to half rho A V cube. This is the empirical relation for wind power. P is half of rho A V cube. It is derived from the kinetic energy, and the P is the power in watts, and rho is the density of the air kg per meter cube. A, area wind passing through the through perpendicular to the wind, that is the swept area of the blade, that is the A, and V, that is the wind velocity meter per second. So, in this empirical relation, and it gives the wind power, and to increase the wind power we cannot have hold on the velocity. Velocity is nature, we cannot do anything on that, V cannot be altered, and the rho also it is air density. So, we cannot touch that. So, rho and V cube depends upon the site, but A, it is in our hand. So, and when we increase the swept area, definitely the power output also can be increased, but then we cannot keep on increasing it, and it has its own limitation, and it should be optimized. So, this is the empirical relation to get the wind power, and these are all the various wind turbine technologies. Wind turbine converts the energy of the wind into electrical energy, converts airflow into mechanical motion, and gives the electrical power. And there are several types of wind turbines convert useful energy. They are propeller type and multi type, Savonius and Darius. And propeller type and multi type, it is mostly it is a horizontal axis wind turbine, and Savonius and Darius are vertical axis wind turbine. These are all various types of wind turbines available. And this is about the vertical axis wind turbine, and this is the shape of the blade, and I mean all the controls are closer to the ground, and when the wind flow hits the blade, it revolves, and wind direction is does not matter here. From any direction wind can flow and it can revolve. So, that is the main advantage of vertical axis turbine is, and any direction the wind can flow and it can revolve either direction, and of course, we can go for lower capacity turbines, and the maintenance is easier because all operations are closer to the ground, and we can have less capacity machines. And this is another type of vertical axis. We can have various designs, and these are all vertical axis type various types, and here there are different kind of blades and various categories of blades. People kept on varying the design, and they change the material and they change the design to get maximum efficiency of it. So, in the vertical axis wind turbine, and these are all several blades are being used in the vertical axis wind turbine. And apart from it, this is about horizontal axis wind turbine, and it is commonly used, and it is commercially it is acceptable, well mature technology, and it has a lot of features over vertical axis wind turbine, and it has 3 blades. Of course, initially it had 1 blade, 2 blade, 3 blade, multi blades, but then now it is optimized 3 blades turbine for the horizontal axis wind turbine. And here about various types of horizontal axis wind turbine blades, and this is single blade and double blade and 3 blade and multi blade and upwind and downwind, various designs people designed, and apart from all this designs, 3 blade types, and this is the best type, and it is optimized one, and nowadays it is acceptable, and all over the world the 3 blade turbine, the horizontal axis turbine is being installed for the electricity generation. And this is about the little comparison between the vertical axis and horizontal axis wind turbine. The vertical axis, it is less efficient when compared with the horizontal axis, does not depend on wind direction. Wind direction, it may be from any direction, it accepts the wind velocity. It needs less starting torque, and these are the main aspects of vertical axis wind turbine. When we look at the horizontal axis wind turbine, it is highly efficient when compared with a vertical axis wind turbine, and it is oriented towards the wind direction. So, and it will be, the hub will be turned according to the wind direction, and which is operated by yaw mechanism. There is yaw mechanism, it is incorporated in the horizontal axis wind turbine, and according to the wind direction, the hub, the blade, the face of the hub, all front side of the blade, it will be twisted according to the wind direction, and high starting torque it requires. And here offshore features as applicable to horizontal type, and it is situated in the offshore, and it receives very good wind velocity because there is no obstruction, no trees across, no buildings across, and it is exposed to the open air, and it receives very high wind velocity, and it is situated in the sea, that is called offshore. Of course, the sea level is shallow, particularly the Mediterranean Sea. A lot of European countries have installed their wind turbines in the sea, that is offshore, and again it is horizontal axis wind turbine. And these are some of the advantages of vertical axis wind turbine. And the vertical axis wind turbine, it does not need the yaw mechanism, and it can be located nearer to the ground, and making it easier to maintain the moving parts, and have lower wind startup speeds compared to horizontal axis wind turbines. May be built at locations where taller structures are prohibited, can be mounted on rooftops, mesas and hilltops and ridge lines. And the main advantages of the vertical axis wind turbines are, and it does not require any yaw mechanism because it accepts any direction of wind speed. The wind can come from any direction it accepts, and all the controls are located closer to the ground, so the maintenance is easier, and it needs only the less startup wind speed for the operation, and it can be mounted on rooftops of the buildings, and this is mainly for low capacity turbines. It has some disadvantage, and most vertical axis wind turbines have an average decreased efficiency from a common horizontal axis wind turbine. When we compare with horizontal axis wind turbine, it gives less efficiency, and have rotors located closer to the ground where wind speeds are lower and do not take advantage of higher wind speeds above. And here, and since it is closer to the ground, and it cannot have access with high wind velocity, that is the main disadvantage. An advantage of horizontal axis wind turbine, the taller tower base allows access to stronger wind, and the horizontal axis wind turbine has tall tower, it has access to the stronger wind. It is high efficiency when compared with vertical axis, commonly used to produce electricity. It has some disadvantage, and massive tower construction is required to support the heavier blades and gearbox and generator. The gearbox and generator and blades are so heavy, and it needs massive tower construction, and downwind variants suffer from fatigue and structural failure caused by turbulence when a blade passes through the tower's wind shadow. Requires an additional yaw control mechanism, it turn the blades towards the wind. It needs additional yaw control, again it becomes expensive. Requires a braking or yawing device in high wind speeds to stop the turbine and from spinning and destroying. These are all some of the disadvantages. In this lecture, and we have seen various types of wind turbines, and what kind of say velocity is required, and the comparisons of horizontal axis and vertical axis wind turbines, and advantages and disadvantages of horizontal axis and vertical axis wind turbines, and everything is being covered in this particular module, and thank you for listening.